All right, so in 5.2, talking about polynomials and polynomial functions. So first, just starting to talk about what a polynomial is. So at the basic level, right, if we go back to Algebra 1, right, we talked about what monomials are. And there are three parts to a monomial. So if I have something like 2x cubed here, right, there are three parts. We have some kind of a coefficient. We have a variable. And we have an exponent. All right, so I'm going to refer to these kind of throughout the entire section, so this way we're all on the same page. Right, I have my coefficient, I have my variable, and my exponent. Okay, so if you think about different prefixes, right, mono 1, bi 2, so it would make sense then that with a binomial, I have two monomials. Right, so two monomials, and the way we have two monomials is if they're joined together by addition or subtraction. So for example, maybe I have something like 2x squared minus 3x. Right, I have my two monomials, 1, 2, and they're joined together by, in this case, subtraction. Following prefixes again, tri, 3, think like a tricycle, right? So three monomials, same idea. Joined by addition or subtraction. So for example, I could have something like this. I could have, it's not a great color. I could have something like, build off on our last example, 2x squared minus 3x plus 5. Right, I have three terms, trinomial, 3. We've talked about these binomials and trinomials already when we've talked about foiling and factoring, right, going from trinomials to binomials and vice versa. Well, now we're going to take it one step further and talk about these polynomials. Right, so if you've heard in other classes about, say, polytheism or, I don't know, polyester, right, anything with that poly prefix, poly means many, right, polytheism, many gods, polynomial, many monomials. So this would be many, just some unknown number. It doesn't matter how many. Monomials, and again, joined by addition or subtraction. So this is kind of my catch-all term, right? This could mean, many can mean anything from 1 to 100,000, right? It doesn't matter. It just means a whole bunch. Right, so something like this, if I consider, not yet, if I consider just this is a polynomial and I can say, that's the eraser, 4x to the 5th minus 2x to the 4th plus 3x cubed plus x squared minus x plus 17. And it looks really long and it looks really scary, but if we really look at it, it's just a whole bunch of monomials that I'm circling all joined together. So this is my polynomial, right? And if I want to take this one step farther, I could say, I could have a polynomial function, right? And all a polynomial function is just a function that is a polynomial, right? So that fancy phrase is just exactly what we've already been talking about, just with a new name. Right? It's a polynomial function because now I've got the little function notation in front of it. Now I can actually do things with it, graph it, find different zeros and intercepts, and that's going to be the focus of the rest of this chapter is how do we find those? What do we do with these polynomial functions? And that's what we're kind of dealing with here. So we have a few different parts of these polynomial functions, a few different important parts. So the first one is what we call our leading coefficient, and that's just whatever number is attached to the highest degree term, our highest power term. So in this case, it would be the 4, right? 5 is my highest power here at all. So my leading coefficient is my 4. course, then my constant is over here is number 17. So my constant is just a term without a variable, right? It's just 17. It's not 17x, it's not 17x squared, it's just 17. It's just the number. So I have my leading coefficient, I have my constant. The other important piece here is the degree. And degree is just a fancy word that means the highest power in the function. That's all it means. It's the highest power in the function. So in this case, my polynomial has degree 5. So maybe I'll write that down. I can say f of x has degree 5. It's a 5th degree polynomial. Some other important things, right? My leading coefficient cannot be 0. Right? That wouldn't make sense. The term wouldn't exist anymore. 0 times anything is 0, so we wouldn't even need to bother writing it. The other important bit is to say that I can have no negative exponents and no fraction exponents. No negative exponents or fractional exponents. So I can't have like a 3x to the negative 2, or I can't have like an x to the 1/3. That wouldn't be a polynomial anymore. So one thing we wanted to define with polynomial is, I've kind of said we have standard forms for everything. We have a standard form for polynomials too. So I'm going to say that a polynomial in standard form, there's my word, standard form, say is written in order of descending power. Right, so just make sure we're on the same page. That means highest to lowest, and then the constant. So descending power. So my polynomial f of x up above, right, this right here, is in standard form, right? I go 5, 4, 3, 2, 1, constant. And we say that the constant has degree 0, so that way just formally we can put it last. Right, so some examples of this. Right, if I were to say 4x cubed plus 6x plus 3, well, this is in standard form. Right, this is in standard form. My powers go from greatest to least. Right, 3, 1, 0. There's no second degree here, but that's okay. We don't care. All we care about is my terms go from highest power to lowest power. Right, we could say that my leading coefficient here is 4, and that this is a 3rd degree polynomial because my highest power is 3. And if I look at maybe a different polynomial function, maybe if I look at this one, 3x plus 5 plus 2x to the 4th minus 6x squared. Well, this is not in standard form. Right, this is not in standard form. Why? Because my terms are not written in order from highest power to lowest power, right? If I look at my powers, I have a power of 1 and then a power of 0 because of my constant, a power of 4 and then a power of 2. So if I want to put this in standard form, that's not the color I want, there we go. In standard form, I'm just going to write this in order. So I have 2x to the 4th minus 6x squared. My signs have to come with it. Plus 3x plus 5. So now my powers are in order, 4, 2, 1, 0. And again, if we want to talk about leading coefficient and all that, my leading coefficient is 2. And my highest power here is 4, so I would say that my degree wherever I can fit it in, is 4. So an example of something that is not in standard form would maybe be this. If I had x to the negative 2 plus 3x to the 1/2, right? This is not even a polynomial at all. Right? That's not even a polynomial at all. I have powers that are negative. Right? I have a negative power, that's bad. And I have a fraction power, that's also bad. Or rational power, that's also bad. Right? I have negative and I have rational powers. So this is definitely not a polynomial, so I can't even bother considering whether or not it's in standard form because it's not even a polynomial to begin with.